Welcome to SUSECON 2022, and thank you for joining our session, SUSE Edge, an introduction, overview, and roadmap. Today we're going to talk about what we're doing at the Edge and why, Kubernetes node onboarding and how to do that best in remote locations, and then what's next for Cloud Native Edge here at SUSE. My name is Andrew Gracey. I am the product manager for Cloud Native Edge. And yeah, let's get it going. So first off, what we are doing and why. So how we think about Edge is we kind of have these three and kind of a fourth section, right? So for the near Edge, we're typically talking about telecom use case or a really well-connected location to the data center, where you might have a couple nodes, but you're not really a full data center. You're probably half rack at most. And more importantly, you're going to be, these servers are actually somewhere in a remote location where getting to them can be potentially very expensive or just they're wholly inaccessible. And also, you probably only have maybe 10 to 100, maybe 1,000 locations for this near edge. So for the far edge, we're kind of more talking about retail, transportation, public sector. Typically, we're looking at locations that probably have 3 to 5 nodes, maybe 1 or 2 for something even smaller. But you're probably looking at like a retail location or restaurant where you maybe have a couple thousand of these, potentially tens of thousands of these locations across the world. And with that, you also have all of the constraints of, again, similar to near edge, where you don't want to have to send somebody on site. You don't want to have to, you might not know when you're shipping out a device where it might go, or you might not have the best shipping policies around that type of thing. And you also probably are more space constrained on actual like form factor of the computer that you're using as a server, as well as you are likely using like commodity hardware such as like a Nook or a Raspberry Pi or something along those lines. We also have the distributed data center, which is not shown here. This is something that we're kind of starting to find a lot more, but it's kind of somewhere in between the near edge and far edge in terms of compute and numbers, but you're probably going to have more nodes per cluster. Think like a manufacturing floor where you will have maybe a cluster that spans a portion of your supply chain, for example, so that it can all talk to each other. All of the devices in there can all talk to each other very nicely and seamlessly. But it's still edge in the sense that it's not a data center, right? You still maybe don't want to have to send a technician on site if you have a bunch of different manufacturing locations. And then farther on the right, we've got the tiny edge. These are the devices that actually connect to the physical world. They might be the last ones that you would expect to actually be using Kubernetes or cloud native ideas. But yeah, so each of these has a different need and have different constraints. But we do believe that bringing some of the cloud native ideas to these areas can provide value. Namely, declarative deployments and being able to work with GitOps is a huge value when you're working with potentially tens or hundreds of thousands of devices or clusters. And similarly, the way you get declarative deployments is through the reconciliation loop. And so being able to push the reconciliation loop and keep your cluster even at the edge, HA, and self-reliant, but then also kind of having these layered loops of reconciliation further up the stack really gives a lot of value in being able to manage each of the all the devices that you have in your infrastructure. So with just the combined portfolio of SUSE and Rancher, we can provide a large portion of the stack needed for each of these verticals. For the near edge, we can use our Rancher Kubernetes engine version 2 on top of Sleep Micro. This combination provides us all of the kernel parameters, all of the drivers, the real-time kernel options, the all the networking options that RKE2 provides, such as like Multus and Calico, Cilium. Allows you to really kind of start working with and giving much more higher performance and throughput on these devices. It also gives you the flexibility that's needed for telco or other highly connected use cases and locations. Because really what we're seeing in near edge is that you might be working with much more powerful hardware, but you also have much more specific needs on, say, like for example, like the radio access network has very specific needs for latency and jitter. So you have to really work with the full stack to make sure that everything is timed appropriately. And RK2 and Sleep Micro allows us to get that. For far edge, we can leverage K3s to provide the best lightweight Kubernetes on the market. And then we can put that on top of a purpose-built operating system that we're going to talk about just a little bit that is based on top, or it is Sleep Micro 5.2 and going forward. And we can do that to be able to shrink the overhead and allow you to both the operational and the compute overhead to allow you to make the most of your hardware and make people's lives who are having to manage this much easier. For Tiny Edge, this is something that we are still looking into, and I'll kind of talk about some of the pieces that we're looking at further on in the presentation. But yeah, for looking at industrial IoT going forward, this is something that we will be doing a lot of research into. So to build onto what we already have and what's already working, we want to improve the node onboarding experience at the edge. Our goals for this whole stack are really to reduce the operational costs by providing the tool set to be able to make deploying a node into remote locations more streamlined and less error prone. Like I mentioned, like you probably are not your core competency, the core competency of your company is likely not logistics. And if you are a logistics company, then you probably will know how hard some of these things can be. But we want to make sure that if at any time during the provisioning process, a human mistake gets made because things happen. We want to make sure that we're able to recover from that. We're not locked into anything. Everything should be very flexible while still being secure. We also know that sending technicians onto site can be very expensive. So we would rather allow you to have basically be able to hand a store manager a set of hardware, have them plug in power and network, and press the power button and walk away. And once they do that, everything else should be able to be managed from a central location, and in this case specifically Rancher Manager. And yeah, again, we really don't want to have you fly out an engineer to a location just to fix something that could be very easily done with a remote connection. So to do this, we've really focused on 3 different areas. We have the onboarding, and so this is basically how do we get a node into Rancher Manager's inventory so that Rancher can create clusters and manage it. We do this with a couple different components. We built a machine registration service that allows basically machines to be able to register themselves, or you can lock that down and be able to manually register machines so that Rancher knows about them. The way that we identify machines is we actually take a known value and hash it with the Trusted Platform module that is built into it's either a chip or built into your firmware, but is unique to this piece of hardware. With this hash, we're able to then call back home to Rancher to say, hey, this is me, give me any instructions. Potentially run some custom scripts to be able to say when the node actually boots up in its remote location, be able to maybe figure out where it is in the world, what like say store ID it's attached to, what network it's on, those type of things. Um, and all of this is being backed by a toolkit called Elemental that allows us to work with an operating system that is actually packaged as a OCI image. So we are using the OCI image spec to package up our operating system, lay it onto the device, and then do updates, which I'll discuss in just a moment. It's a really cool technology and it really enables some really interesting use cases and some really streamlined flows. So we also have the cluster management. This is what Rancher excels at, or one of the things that Rancher excels at. But so once we have nodes that are onboarded into our inventory, we can then go ahead and start assigning nodes into clusters. This can be pretty easily done. We talked to, if you saw the keynote, Basil talked quite a bit about this, and I'm gonna kind of do maybe a little bit deeper dive into how everything works in a couple slides. So yeah, so this is honestly your standard cluster lifecycle management, right? Everything works exactly the way that you would expect. You can define if this new cluster is going to be RKE2, RK3S, what parameters it has, additional manifests, really everything that Rancher allows you to do already. It allows you, we get the same control because we're just using Rancher's provisioning v2 framework. So last off, and where we can kind of give a significant amount of additional value is that we can also manage the operating system itself and the lifecycle. So like I mentioned, we're using OCI images to distribute the operating system, and we can kind of break it up by layers. We can do a lot of interesting things to be able to reduce the amount of traffic that's consuming. And with the setup that we have, we're able to basically from Rancher itself upgrade the operating system and do AB over the air style updates with saying backoffs if or rollbacks if something goes wrong. And yeah, and it allows us just to give that one additional layer of stack control into the same place with all the same pathways and same tooling that you already know. So the onboarding flow looks. I'm just going to go ahead and build this out. The onboarding flow is basically this. So we have. So you would start off, and this would probably already be done for you, but you would install our new onboarding services or enable those. You would do some configuration on around how machines should actually look like for example, what device they should be installed onto. You can set up cluster init type rules. And you can set up, and basically you can use this to be able to build a bootstrap image from that knows how to call home to Rancher, as well as know how to install the operating system onto disk. So when you once you build this image, and you only need one image for your entire infrastructure, if you've got, for example, if you've got the same type of machines. So you don't have to build specific images for each cluster or each node or anything like that. You can just build one and then boot all of your machines with this onboarding image. And when it boots, it will install itself onto the specified drive. Yeah, so once when it calls home, it registers itself and lays itself onto the drive. It will reboot, and you pull out the ISO or USB drive, or however you're booting this machine, and you power it down and you ship it out to the remote location. You don't have to do anything past that. You don't have to tell it what cluster it is, where it's going to be, anything like that. So once you ship it out to the location, the say let's for example, let's say it's a retail store. Your store manager plugs in all of your nodes, all the nodes that they got shipped to them. Those nodes call home to Rancher. The Rancher says, "Okay, cool, run the script and tell me what the results are." That script can be customized based on what your infrastructure needs are. And then potentially from that output of that script, or if you already know and you've got really good tracking of where things went, you're able to then create a cluster with these machines set up in that cluster. So you can say, okay, cool, I've got 3 nodes. Are all going to be I'm going to do a 3-node Kubernetes cluster with all of them being control planes, right? Super easy. Once that happens, Rancher Manager will turn around and tell each of the nodes that just got assigned, hey, here's how you bootstrap yourself into this cluster and start the cluster up. Then the cluster is created, it calls home. That cluster then pulls Rancher agent and fleet agent, as well as all the config that it needs, and now is ready for management via Rancher or fleet. And then from that point, fleet can just take over and schedule all of the workload that you've already assigned for it. And it can do that in just one more note. It can do that with labels. So you don't have to even be specific about which clusters. You can just say all the clusters with XYZ label will get this certain workload. And so when you create the cluster, you just give it a label, and that's all you need to do. And then all of the workloads that target that label will get deployed automatically. It's a really slick system. So then once you have basically from the last slide, everything is running, that should stay healthy for as long as you need. But at some point, CVs happen, right? So we will publish a new operating system image as an OCI, and inside of that we will come any like CV fixes, any kernel patches, right? Anything that you would need, and then your Rancher instance will be able to see, hey, there's a new operating system image available, and flag it up on the UI or some alert saying, hey, do you want to upgrade, right? So at that point, the admin would actually go in and update which OCI image spec would be used for these target clusters. Similar to how Fleet does, you can do labeling or select specific clusters to get this update. So you can do canary deployments of operating systems and kind of whatever flexibility you need there. And then Fleet will pick that up and produce a plan and provide that to the system update controller. And then that will turn around and start a rolling update in your cluster. So with that, you're able to say, okay, cool. I need to respect pod disruption policies. I need to make sure that things get cordoned and drained if that's how you want to manage things. And in general, we'll make sure that only in however many nodes you define can do the update at one time. And then if something happens in this update, it does know how to roll back. But because we actually are using a couple different partitions inside of our operating system, the way we do an update is by a partition flip. So we actually lay down the new OCI image onto disk, switch the grub labels for the different partitions, and reboot. When that reboot happens, it comes back up just as on the new operating system. Because we also have a persistent partition that's holding your persistent volumes, any etcd information, all of your K3s version binaries, it will actually just come back up as if it was just a normal reboot, but now it's got a new operating system. This allows us to again give you over-the-air style updates in a very flexible but also a consistent way across all of your infrastructure. Yeah, so with that, that's going to be out later this fall, and you should be yeah, definitely talk to your sales teams about that if you find that type of infrastructure and operating system management within Kubernetes interesting for you. So what's coming up next? We've got kind of the middle of the stack at the moment. So we want to move up the stack as well as down the stack. So for going down the stack, we are looking at bare metal management, specifically looking at cluster API being driven by probably either Metal Cubed or Tinkerbell. We're doing some research on that right now and a couple proof of concepts with a few customers to help us do some research on where each one makes the most sense. And with these technologies, this will allow us to actually do either PXE booting or baseboard management to be able to lay down the operating system in the first place, right? So you can just ship out a completely blank set of hardware and then manage it through again whatever bare metal infrastructure provider we go with. We are hoping that we can do the research for this later this year and start having support for these capabilities going forward. And yeah, with this, we'll basically be able to support all the way from your IPMI layer all the way up to the Kubernetes layer. And this also provides some additional security around the actual bootstrapping process, because obviously there's less time in between for somebody to eavesdrop or to make any alterations to your hardware. And then moving farther up the stack, we're looking at Project Acri. What this does, and you saw probably a little bit of this in the keynote again. And with this, what it allows us to do is actually do discovery of our peripheral devices. This can both be devices that are actually plugged in and physically attached to these nodes. For example, like a USB keyboard, a serial bus, honestly kind of maybe an X11 session, right? Or Wayland session, kind of whatever this needs to be. And the way this is done is in a very modular way. So if you have some crazy custom device, or you're a vendor of a crazy custom device, you can build a discovery handler that will be able to tell Acri what this device is, how to access it, what credentials, kind of whatever that needs to look like for your devices, so that it can turn around and pass those into the actual workload that's scheduled for that. All of this is being done very declaratively, and I totally just made a mistake on my slide on this. And ignore the third bullet point here. That's careless copy and paste. But yeah, so basically, Acri gives us the ability to give a very descriptive way to approach where you might not have a very heterogeneous environment across all of your different clusters. So it allows us to be very flexible with what's actually there. For Fleet, we also have Fleet. Fleet can give you a very nice way to do the deployments to each of the clusters in a very flexible way, where you can have many-to-many relationships between things being deployed and the targets. and then we can actually start using Fleet to deploy Acri, so you can give a very, very seamless integration there. Um, yeah, and so with that, thank you, and definitely feel free to email me or let me know if you've got any questions, or definitely talk to your to your representative at SUSE and Rancher. So thank you. Bye.